In question 9, the second term of a geometric progression is 16 and the sum to infinity is 100. We have to find the two possible values of the first term. Now we know that the nth term is given by ar to the power n minus 1. As the second term is 16, we'll write 16 is equals to ar and 2 minus 1 will be 1. The sum to infinity is 100 as the formula is a upon 1 minus r. So we'll write 100 is equals to a upon 1 minus r. So now we have two equations and two variables a and r. So from the second equation, we can say that a is equals to 100 into 1 minus r. Substituting this in the first equation, we'll get 16 is equals to a into uh, in in place of a, we will write 100 into 1 minus r times r. So this will become 100 r minus 100 r squared equals to 16. Taking the r squared on the left hand side to make it positive, we'll get 100 r squared minus 100 r plus 16 equals to 0. Dividing it by 4 to make it simple, the equation will become 25 r squared minus 25 r plus 4 equals to 0. Now we can factorize it by middle term breaking. So this will become minus 20r minus 5r plus 4 equals to 0. Taking 5r common from over here, we'll get 5r minus 4, and taking 1 common, we'll get 5r minus 4 equals to 0. Finally, we'll write this as 5r minus 1 and 5r minus 4 equals to 0. So the two values of r will be r equals to 1 upon 5 and r equals to 4 upon 5. Now, once we have the values of r, we can find the value of a using the equation 16 equals to ar. As we have to find the two possible values, so as ar was equals to 16, if in place of r we put 1 upon 5, the value of a will be equals to 80. And if in place of r we substituted with 4 upon 5 equals to 16, so this will be 16 times 5, 80 upon 4. So the other value of a will be equals to 20. In part B, it is saying that show that the nth term of one of the two possible geometric progressions. Now, as we had two values of a, so for the nth term, one of the formula will be 20, and for 20 we took the common, when we got a as 20, the common ratio was 4 upon 5. The formula will be 4 upon 5 to the power n minus 1, and the other geometric progression, as the first term was 80, the common ratio was taken as 1 upon 5, so this will be 1 upon 5 to the power n minus 1. Now it is saying that we have to show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2 multiplied by the nth term of the other geometric progression. So what we have to do is we have to multiply one of these expressions with 4n minus 2 and prove that it is equal to the other nth term. So let's start with multiplying 20 into 4 upon 5 to the power n minus 1, and we'll multiply it by 4 into the power minus 2. So opening this bracket up, 4n minus 1 will become 4n into 4 to the power minus 1, and 5 will become 5n into 5 to the power minus 1 multiplied by 4n into 4 to the power minus 2. So we can simplify this. This 4 will become a denominator. So we can bring this 4 and 4 square in the denominator. So this will become 20 upon, we can write this as 4 into 4 squared. In the numerator, we'll have 4n and 4n. And 5 power n and 5 power minus 1 will remain as it is. Now, for the other term, it would have been 80 upon, so this would have remained 1, 5n into 5 power minus 1. So simplifying this would have become 80, and bringing 5 power minus 1 in the numerator, this would have been 5 upon 5 to the power n. So we can see that these two terms are not equal. So now in the next step, we'll multiply this expression and see if we can get the expression for the nth term where a was 20. Now multiplying this other nth term, 80 into 1 upon 5 to the power n minus 1, multiplying it by 4n to the power minus 2, we'll get 80 into 1 upon 5n into 5 power minus 1 multiplied by 4n into 4 power minus 2. So keeping 4 power n in the numerator will bring 4 power minus 2 in the denominator. This will become 80 upon 16. And we can leave 4 power n and 5 power n into 5 power minus 1 as it is. As 80 upon 16 is 5, so this will be 5 into 4 power n upon 5 power n into 5 power minus 1. So the nth term with 820 and r was 4 upon 5. So that will become 20 into 4 upon 5 to the power n minus 1. Opening the bracket up, we'll get 20 into 4n into 4 power minus 1 upon 5n into 5 power minus 1. Now 4 power minus 1 will come in the denominator. That will become a 20 upon 4 into 4n, and the denominator will be 5n into 5 power minus 1. So 4 and 20 will cancel out to become 5. So we'll get 5 into 4 power n divided by 5 into 5 power minus 1, which is now equal to the term when we multiplied 80 by 4n minus 2. So multiplying this term where a was 20 by 4n minus 2 was not equal to multiplying 80 by was not equal to the term with 80 as a and r is 1 upon 5. However, when you multiplied the other term where a was 80 and r was 1 upon 5 with 4n minus 2, we can see that it was equal to the term where a was 20 and r was 4 upon 5.